Hey boys and girls, it feels like Christmas vacation was so long. It was great. I rested up, but I am so excited to see you and get back to business. So here's our first flipped video of the new year. Our I can statement is I can identify different types of lines and angles. We're going to be switching gears from computation to geometry. So this is going to be the first in a series of geometry videos. Make sure you have your paper and pencil, and then let's get started. Okay, we're going to get started by talking about different kinds of lines. Mathematicians represent lines in different ways. You might see a line, helps if I have my pen turned on, that is represented that looks like this. You might see one that looks like this. And you also might see one that looks like this. And of course, they can be going any direction. I drew mine all horizontal. They could be going any direction. But let's put some names to these lines. So this one, the first one that I drew up here at the top, this one is a line. Wow, that's really big. Tone that down a little. Okay, this is a line, and it has arrows on both ends, so that tells me that this continues in both directions forever. Forever. Okay, so this is a line. The next one is a line segment. And that means it's part of line or a piece of a line, and I can tell that by these endpoints or the dots on the end. So that's just a piece of a line, and a lot of times mathematicians will label it. So they'll label the endpoint A and B, and then they'll call this line segment AB. And we put a little line over it to show that it's a line segment. The one at the bottom is called a ray, and this is a line that has an endpoint, so I'm going to label my endpoint C. Okay, and it goes on forever, but it goes on forever in only one direction. Okay? Okay, another type of lines are called parallel lines. These lines go on forever in the same direction. They're equal distance apart, so they're next to each other. They're most like railroad tracks. So they're equal distance apart, so they stay equal distance apart the whole way, and that is how we know that they are parallel. So think in your head about other things in real life that are parallel. I'll give you some examples. Like I'm in the classroom right now, and I'm looking at the window blinds and the actual shafts that make up the blind, the part that turns. Those are equal distance apart, and they're running the same direction. So those are parallel. The tiles on the floor, the lines that are created by the tiles on the floor, those are equal distance apart, and they run the same direction. So think in your head, write down some examples. What are some things you see in nature or around you that are equal distance apart and travel next to each other? They never cross. So parallel lines never cross each other. So if you think about a railroad, even though it might curve, they stay equal distance apart. They never intersect. So think about what are some other examples of parallel lines and write those down on your paper. So if parallel lines are equal distance apart and never cross, intersecting lines are kind of the opposite of that. These are lines that cross each other at some point. So they could cross each other like this. They could run what appears to be parallel all the way to the end and then intersect. So lines that cross each other are called intersecting lines. Now, parallel lines never intersect. That's what makes them parallel. Okay, the last type of line that we're going to talk about are called perpendicular lines. Can you say that with me? It's a long word. Perpendicular. Okay, so we talked about parallel lines, lines that are equal distance apart that never cross. We've talked about intersecting lines, lines that cross at some point. Perpendicular lines are intersecting lines and they cross at exactly 90 degrees. So mathematicians talk about where two lines intersect. That's called an angle. And we're going to talk more about that in a minute. So an angle is where two lines intersect. And what does intersect mean? It means to cross. And they assign that a value. So in this case, where the value that where perpendicular lines intersect is exactly 90 degrees. And if you look, it makes a perfect square. And in fact, mathematicians use the symbol of a square to indicate that that is a 90 degrees or a right angle, which we're going to talk about in a minute. So perpendicular lines cross at or intersect at a right angle. So it could look like this, which I've drawn what looks like a big a plus sign or a cross. It could look like, I'm going to draw some other examples over here. It could look like a T. It could look like an L. And of course, these could be reversed or upside down. It could even look like an X if they are 90 degrees. And there's one way to check. In the classroom, we're going to use square tiles, but you could take the square edge of your notebook paper, and if you could fit it into that, then that's 90 degrees. So perpendicular lines cross at 90 degrees. Okay, so let's put all this knowledge about lines into practice. I've kind of drawn what's supposed to be a street map, and you'll notice that all my streets have names. So, of course, they're the names of the color that I drew them in. Very original, Mrs. Young. So here is Green Street, Purple Street, Yellow Street, Blue Street, and Pink Street. So on your paper, what I want you to do is I want you to write down some examples of parallel lines. So what two streets are parallel? Write those down. What two streets are perpendicular? If you can find more than one example, that would be great. What streets are intersecting? So write down those examples. So I want parallel lines, the names of the streets that are parallel. I want perpendicular lines. Remember, those meet at a 90-degree angle or a square corner. And I want intersecting lines. So those lines cross each other, but not at a 90-degree angle, not at a perfect square. Okay, so write down those examples, and then we'll come back and talk about it. Okay, I hope you found some great examples. So we're going to go over them. Green streets and pink streets are parallel. In addition, blue streets and purple street are parallel. Now, there were quite a few examples of perpendicular. You could have had green and purple. Right there is your 90-degree angle. You could have also had green and blue. Same thing. You could have purple and pink or blue and pink. Those are your perpendicular lines. Intersecting lines. Yellow and any of these. Yellow and green, yellow and pink, yellow and purple, yellow and blue. Those are all intersecting lines. Okay. All right, we're going to move on to angles now. Okay, we're going to switch gears and talk about angles. We talked about them briefly when we talked about how to tell what line is perpendicular, but we're going to look at the definition again. So we said an angle is created when two lines intersect. And what does intersect mean? I hope you said cross. And it's measured in degrees. And you're probably familiar with degrees when we talk about temperature, but we're going to talk about degrees in a different way. So if you talk about a circle, mathematicians say that a circle contains 360 degrees, and we use the little symbol just like we do for temperature. Okay, when we divide a circle in half, half of 360 is 180, and when you divide that 180 in half, you get 90. So that's when I was talking about what we call a right angle. A right angle is measured by 90 degrees. So right angle is equal to exactly 90 degrees. So that's where we get that perfect square. And remember, it could be shaped like a T or an L or even an X, but that's 90 degrees. So a right angle is 90 degrees. Okay, so what do we call something if it's more or less than 90 degrees? 90 degrees is that perfect square. So what do we call something if it's more or less than 90 degrees? So I'm going to start with my half a circle or my line that we said was 180 degrees. And if I come off of that 8 looks horrible. If I come off of that and I make my angle, so let's say first I'm going to show you that that's our 90 degrees, right? This is our right angle. Okay, what if I come off of that and I say that my angle is right here? Well, is that more or less than 90? Well, if this, I'm going to pick a different color. I'm using a lot of colors today. If this is exactly 90, then what I've drawn there is less than 90. So if it's less than 90, we call it acute. And I always say it like this, acute, because it's so little cute, because it's teeny tiny, it's cute. So it's acute, okay? If it's less than 90, we call it acute. Okay, so what about if it's bigger than 90? So let me show you another slide. Okay, so I've got my 180 degrees. Halfway right here is 90. That's my perfect square. Okay, this time though, I'm going to draw my angle and I'm going to put it in like this. So this time, when I look, I'm looking at this part. And you can see that right here is my 90. Well, that's much larger than a right angle. So we call this obtuse. Obtuse. Okay? So the last one, what was it? Acute, because it was teeny tiny. And this one we call obtuse, because it's big, bigger than 90. So a perfect square is a right angle, okay, 90 degrees. Smaller than 90 is called acute. And bigger than 90 degrees is called obtuse, okay? And you're going to need to know all of these different types of lines and different types of angles because it's going to come into play when we check the attributes of different types of three-dimensional shapes. Okay, so this is just a preview of what we have to learn. So we will talk about this video in a couple of days, and we've come to the end, so it's time for the riddle of the video. Okay, here it is. Why don't aliens eat clowns? Because they taste funny. Okay, I can't wait to start this unit with you. We got some cool stuff in store. So I'll look forward to seeing you in class. Thanks. Bye.